During this video, we will present a demonstration on the monitoring, identification, and capacity management of a network as a service. Additionally, we will show how to publish and request a service using OpenCAPIF framework in an easy interface. Let's quickly review the main objectives of the project, the new capacities, and the components that will be involved in the demonstration. NOS 6G is a R&D project of UNICO 5G program, with European funds, that explores new capabilities such as network accessibility, adaptability for real-time dynamic adjustments, interoperability to facilitate the integration of new services, as well as efficiency in resource usage and resilience through automated AI-based management. Here we can see an overview of the project's architecture. The data source will be provided by the operator network and will be consumed by the services through the Network Data Analytics function, NWDAF. To validate the new network capabilities, the project has integrated SEAL, Edge App, NEF and NWDAF over the network as a service layer. The project's use cases will leverage these services exposed in OpenCAPIF, and in this way the user experience will improve. We can see an example of a use case where AI is utilized through a component called HyperAI, which leverages network data to enhance the user experience in scenarios of data congestion. Additionally, other data sources can be used. In our case, we incorporate real-time weather conditions in the area and news sources reporting crowd gatherings or incidents to decide if Open Gateway service should be activated. In the following demo example, from the project's interface NAAS, we have demonstrated it is very easy to publish a service associated with a provider in OpenCAPIF. If we overview the interface, we can see general information about the services. To publish a service, we can access the specific section. After completing the basic service information in the form, the service will be published within a few seconds. It is necessary to enter the credentials for service publication, as well as the IP address, port, and additional basic information. If after publication, we access the OpenCAPIF administration portal, we can see that the service has been successfully published. The published service appears in the API list, and we can view the information associated with the service. On the other hand, when making a request to the service, it is possible to view its status in the corresponding section of the portal. Let's analyze the congestion service activation from a user perspective. Sometimes, service quality in scenarios like concerts or sporting events is not optimal, and it is not always easy to predict service degradation. How does it work in a real congestion scenario? For example, in Valencia, consider a user attending a football match at Mesalla Stadium. We can analyze the predictions obtained by NWDAF on match day. By comparing the 1-hour predictions with real data, we see that the predictions anticipate the traffic increase. Thus, if the system detects a rise in connections and PRB usage starts congesting, it will trigger the take into account this info to execute the better action. If we revisit the flow as a recap, we see that through HyperAI, network information and data are obtained and used to define the decision that should be applied to the network. In this case, once an alert scenario related to congestion is identified, the service will make a request to Open Gateway to enhance the user experience in the area. As a result, these users experience an improved service, seamlessly and transparently. In summary, we have demonstrated how to publish and request services in OpenCAPIF, and how we can transform network data into AI services.